Hi everyone, this video is part of Macquarie University's coding tutorials, and in this video, we'll be discussing class constructors, what they do, and the various types we can create. Constructors in Java are special methods that are used to initialize objects when they are created. Currently, we've simply been allocating new memory for an object to be created, and then manually changing the instance variables. But what if we could specify the values we want as we create the object itself? This is where we need to create some sort of custom constructor. Let's first create a constructor and then analyze it to understand the features and syntax. If we look at the instance variables we have, we can see that make, model, year, and number of seats are all attributes that someone creating a car should specify, whereas current speed and is running should be left as defaults when the object is created. That is, the current speed would always start at 0, and the is running variable should always be false, as the car will be off when first created. So we need to keep in mind that we just need a way for someone creating a car object to specify the make, model, year, and number of seats they want. Let's start creating this constructor by using the word public and then the class name, which is the same as the constructor's name. We have to write the same name exactly, making sure in this case to use a capital C. Notice also, we don't use the word static and we don't have any return type at all. These are the ways you can tell if a function is a constructor, and they are usually written at the top of a class, but beneath the attributes. Now for someone to specify the make, model, year, and number of seats, we need to add parameters to this constructor. Let's call them the same as the instance attributes and make sure they have the same types. We could use different parameter names, but in this case we'll use the same to illustrate an important concept we need to know. We write string make, string model, int year, and int number of seats. Now inside the constructor, we want to make our instance variable make become the parameter make. So remember, our instance variable goes on the left and our parameter goes on the right. However, right now we are writing make equal make. Which one is which? This is where the this keyword becomes important. This is a reference we can use within a class to refer to whatever object is currently being created or called on. If on the left side, we write this.make instead of just make, the program will know we mean the instance variable of the object being created with that constructor call. Because of the way scope rules work, if we just write make by itself on the right hand side, the constructor knows that we are referring to the parameter. With the this keyword, you can think of it this way. If an attribute or method is non-static, the class knows that it will be called upon on an instance of an object. For example, we have to do mycar.make to access the make of my car. However, inside the class, the object doesn't exist yet. So the class is doing some forward planning by using the this keyword. Once the constructor is called, or an instance method is called on an actual object instance, the this keyword will be replaced with whichever object is being used. You'll notice in our instance methods, we didn't use this, and in those cases it was okay, because it wasn't ambiguous which make or model we meant. Only the instance attributes had those names, so the class implicitly put a this in front of it. Going forward, it's good practice to use this when referring to the instance attributes so we don't accidentally use the wrong variable in cases where there is scope ambiguity. Now back to creating our constructor. We will write this.make equals make, this.model equals model, this.year equals year, and this.number of seats equals number of seats. With this.current speed, we want to initially set it to 0. Because we haven't initialized it when declaring it at the top, it should be 0 by default. But just to make it clear this is intentional, let's write this.currentSpeed equals 0. Now let's also make this.isRunning equal false, since the car is off to start with. Finally, we have the number of cars variable left. Even though this isn't an instance variable, anytime a car is created, we want to increase it by 1. So in the constructor, we need to write number of cars plus plus. Notice that we can't use the this keyword, because the number of cars variable is static. If we encountered the same ambiguity from before with a parameter of the same name being passed in, we could write car.number of cars to ensure that we use the static class variable. Now let's use our constructor in our carTester class. Same as usual, on the left hand side, we declare the object type and name, car, my car. Then we use the new keyword again, write my car with an opening parenthesis. But this time, instead of closing the parentheses, we add in the parameters in the order specified by the constructor we created. We'll write Toyota for the make, Camry for the model, 2020 for the year, and 5 for the number of seats. Now, if we want to print information about our car, we can use the display info method we created in our utility methods video by calling display info on my car. And there we see on the console the information that we expect this car to have, also of the current speed being 0 and is running being false. If we want to see the total number of cars, we can print out car.number of cars, remembering that the number of cars variable is static, and we can see there is one car created, so our constructor is working as expected. Now what happens if we try to create your car with default values like we did before, passing no parameters in? We get a red underline. This is because once we create a constructor explicitly in the class, we no longer have the default constructor available to us. This makes sense, as we might not want for a car to be created without someone specifying its attributes. However, if we wanted a default option, we could create another constructor and not require any parameters. Again, we write public car with a capital C and then leave the parentheses empty. The code inside can also be empty and it will have the same effect of setting all object instance variables to null and any primitive instance variables to 0, because we didn't initialize them at the top. Another type of constructor that is commonly made in a class is a copy constructor. For this part of the video, it is very useful to understand the difference between instance copies and reference copies. We've covered that in this series, so if you need a refresher, please pause this video, watch the one covering that topic, and come back. Let's say we wanted to make your car be an instance copy of my car. Currently, the way we will do that is by creating a new car using the default constructor and one by one changing the instance attributes of your car to be the same as my car. But this is manual, very error prone, and wouldn't be possible if the instance attributes are private. We don't cover visibility in detail in this course, but just know that allowing instance attributes to be directly accessed and modified outside of the class is not good practice. So instance attributes are normally made private. They are then accessed through getters and setters, which are outside of the scope of this course, but could be useful to look into for self-study. Now, as a result, we don't want someone to be accessing the individual instance attributes to create an instance copy. Another idea would be to use the simple constructor we've created and pass in myCar's instance attributes as parameters. But again, we would be accessing myCar's instance attributes directly. And what about the running state and current speed of my car? We would get a car with the same make, model, year, and number of seats, but potentially a different state. Instead, we can create a copy constructor. Here in the car class, we have a new constructor, and we have a car parameter called other. Inside the constructor body, we make all of the this instance variables be equal to the other instance variables, remembering that to change the this attributes, the this keyword has to be on the left-hand side. Then, at the end, we have to remember to increment the number of car static variable, as we would be making another car. Seeing this in practice, we have to create a new car reference like normal, but this time, in the parameter parentheses, we pass the myCar object. The constructor we made will take care of the work of creating an instance copy. Think about how the application of each of the constructors would look in memory diagrams. That is, how does my car and your car look different in each scenario? And that's it for constructors. In this video, we've discussed how to use class constructors to create new objects. We've seen how to create and use a simple constructor, recreate a default constructor, and create a copy constructor in a class. Remember that constructors are special methods that are called when an object is created and they initialize the state of the object. They have no return type, and we can never create two constructors with the same set of parameters. Once we create a customized constructor, we no longer have the default constructor available to us, and we'll have to create it if we want it to be an option when creating an object. In the next video, we'll be taking a look at object interaction as we create more complex instance methods. See you there!